Hi everybody, in this video I'm going to go through our lesson on the triangle proportionality theorem, and first we are going to write out what that actually is. Triangle proportionality theorem. Okie dokie artichokes. So this triangle proportionality theorem states if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. We're going to draw a picture to see what this actually looks like. So if a line, oops, is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. And let's draw a picture here. We're going to draw a triangle ABC first. Look maybe like this. Doesn't have to be perfect. So here's A, here is B, and here is C. And we have a line that is parallel to AB. I'll make that this line DE. And we know that these two lines are parallel, right? I'll write that. AB is parallel to DE within this triangle ABC. So by the triangle proportionality theorem, I know then that DE divides side AC up proportionally to the way it divides BC. So what this really means is that the distance AD over DC, that ratio, how it's divided, is equal to BE over EC. So they're divided up into the same ratio, AD and BE, those are the smaller pieces. Those are both on top. And DC and EC, those are both the larger pieces on the bottom. And then AD and DC on one side and BE and EC on the other side of the equal sign. So this is really what the triangle proportionality theorem means. Also, along with this, we know that the converse of this theorem is true. And if you think back to when we were talking about logic, the converse of a theorem or a statement means you take the hypothesis and the conclusion and you flip it. So this converse theorem is if a line intersects two sides of a triangle and divides those sides proportionally, then the line, right, the line that's intersecting those two sides is parallel to the third side. So if we know the proportional sides, AD over DC is equal to BE over EC, then I can say, okay, then DE must be parallel to AB. So those are the two theorems. Let's look at some examples. These problems might feel kind of familiar. We're kind of looking at similar problems in a different way. So number one, hello. Given that UV oh no, W is parallel to YX, find UV. And this has an image. If you cannot print this out, no worries. Just draw it. So we know based on what the problem says, UW is parallel to YX. So those two lines are parallel, meaning we can use the triangle proportionality theorem. Why am I not abbreviating? Triangle proportionality theorem works here. So because these two lines are parallel and UW intersects these two sides, then I know that YU over UV oops, is equal to WX or XW over WV. The YU over UV is equal to XW over WV. And we can fill in now all of the pieces that we know. YU is 13. So I have 13 over this unknown length of UV. And that is equal to XW, which is 16 over 32. Now I'm going to move this over just a touch. Now I can simply solve, right? Our goal is to find this UV. I can solve by cross multiplying. So I'm going to multiply 13 times 32 and set that equal to 16 times UV. All right, now my second to last step is to multiply. 13 times 32 gives me 416. So 416 is equal to 16 times UV. And then I can divide both sides by that 16. So I divide by 16, and then I get that the actual length of UV is 416 divided by 16 gives me 26. When you actually divide this, you get a length of 26 units. Let's look at another one. Number 2. We are going to find the length of TU. And this one, again, can't print it, just draw it. None of these are too complicated to draw. When I look at this, I notice right off the bat, TW is parallel to UV. So TW is parallel to UV, which means I can use that triangle proportionality theorem. So I can divide, right? U over T is equal to T over S. And then keeping the small side first, WV over WS. Or VW over WS. So just using the triangle proportionality theorem, UT over TS equals WV over WS. And now I can start to fill in my pieces. UT is what we don't know, right? That's TU, essentially. Same thing. So I'm going to leave that as just TU or UT. TS, however, is 50. So I'm going to write it as TU over 50 is equal to VW or WV is 18. And WS, actually, we don't directly know, but I do know the entire length VS is 54. So part of it, right, WS is just the difference, 54 minus that piece we know, 18. And if I subtract 54 minus 18, that tells me then that WS is actually 36. So we have 18 over 36. And now it is time to cross multiply. So I'm going to multiply TU times 36, or 36 times TU, and set that equal to 50 times 18. And if you multiply 50 times 18, you get 900. So we have 36 times TU is equal to 900. My final step then would be divide by 36. So if I divide by 36, the 36's will cancel, and we get TU itself is equal to 900 divided by 36 is 25. So this length here is 25 units. We're going to do one more. This one's my favorite. I always say my favorite ones for the last. Oh, I didn't really mean to do that. There we go. So for this problem, we're going to find JK. And this problem, this diagram actually, is kind of leaving out a lot of information. So first of all, I notice that JH is parallel to KG. So I'm going to write that JH is parallel to KG, which means I can use the triangle proportionality theorem. So I'm going to figure out what sides that would be. So IJ over JK is equal to, on the other side, IH over HG. There we go. Now, what do we actually know? Well, I think I know a little bit more about the yellow side. So I'm going to start with that first. I know that HG is 48. So this is over 48. And IH, I can find similar to how we did in the last problem, right? This is just a piece. We know the entire length, IG, is 72. So to find this IH, I can simply subtract 72 minus 48, which gives me 24 is the length of IH. So I'm going to fill 24 in here. Now let's look at the other side. And I want to remind you, our goal is to find JK. So I am going to let JK just equal X, because that's the length I don't know. So this is X, JK is X, which means then that this piece IJ is 33 minus X, right? Minus JK. Maybe I'll write that first. 33 minus JK, which is really 33 minus X. So my other fraction, I'm going to have IJ first, and we said that IJ is 33 minus X, and that will be over JK, which is just X. So the small piece, 33 minus X, is over the larger piece of X, and that is equal to small piece 24 over larger piece 48. And we can now just cross multiply. So I'm going to multiply the entire entity, the entire binomial, 33 minus X times 48. So I'll put that in front. And that is equal to, multiplying across here, X times 24, or 24X. Now I'm going to show you something kind of neat that I can do here. I could distribute the 48, but it's going to get really nasty if I do that. 48 is actually divisible by 24. So instead of distributing 48, I'm going to just get X all by itself right now, and I'm going to divide both sides by 24. And now I won't be completely done yet, but when I do that, 48 divided by 24 is 2. So I have 2 times 33 minus X. is equal to, well, the 24x divided by 24, the 24's cancel. So I have 2 times 33 minus x is equal to x, and this I can work with a lot easier. So I am going to now distribute that 2 to the 33 into the x, and if you're wondering again how we got that 2, it was 48 divided by 24. 2 times 33 is 66, minus 2 times x is 2x, and that is equal to x. Almost done, almost done. My next step here is going to be to move the negative 2x over to the other side. So I'm going to have to add 2x to both sides, doing the opposite of the subtraction. So the negative 2x and positive will cancel out, and we get 66 is equal to x plus 2x is 3x all together. And almost done, last step is to simply divide by 3. So when we divide by 3, that tells me that x is 66 divided by 3, or 22. And remember, x is what we used for jk. So if x is 22, then I know jk is 22. Please let me know what questions you have on this lesson, and I look forward to seeing you in class.